All right, class, settle down. Welcome to day 5 of 100 Days of Code. Today's topic is typecasting. Pay close attention because understanding this isn't optional, it's absolutely fundamental for any serious programmer. Let's get right to it. We're going to start with a very common and frankly sloppy error that trips up just about every beginner. It looks simple, but it reveals something crucial about how Python thinks about data. So look at this question. In normal math, 5 plus 5 is 10, obviously. But in Python, if you write it like this with the quotes, the answer is not 10. Figuring out why is the key to this entire lesson. The answer you get is 55. Now, why on earth would that happen? Well, it's because you haven't asked Python to do math. Those little quote marks tell Python, hey, these are characters, this is text. So Python does exactly what it's told. It takes the string 5 and just glues the string 5 onto the end of it. This is called concatenation. And sometimes that's exactly what you want. If you have the variable age stored as the string 25, you can easily combine it with age is to make a nice clean sentence. This works perfectly, no problem here. But take away those quotes, so age is now a number, an integer, and try to run the exact same code. Crash. You get this big red type error. This error is a wall every single new programmer hits. But the message is crystal clear. You can only stick a string to another string, not a number. Today, we are going to break right through that wall. So how do we fix this? Well, you have to understand the two ways data types get converted in Python. First, there's the implicit way, where Python kind of does it automatically behind the scenes. And then there's the explicit way, where you are the boss and you give the direct command. And that second one, the explicit conversion, has a proper name, typecasting. This is a deliberate, intentional act. It's you, the programmer, pointing at a piece of data and telling Python, I don't care what you think it is. I am telling you to treat it as this type. You're taking control. Let's look at this side by side. On the left, implicit. This is Python playing it safe. If you add 1 and 1.0, Python sees the decimal and says, whoa, I better make the result a float, 2.0, so we don't lose any information. It's automatic. But on the right, explicit, that's all you. You command the string 21 to become the integer 21. You get all the power, but it also means you're responsible for the consequences. So how do we issue these commands? We use a few built-in functions. I want you to think of these as your essential typecasting toolkit. And these are the big three. You've got integer, which turns things into a whole number. You've got float, which turns things into a number with a decimal point. And you've got string, which can turn almost anything into a string. You master these three functions, and you'll solve the vast majority of your data type problems. Now listen up, because this is a classic gotcha. The official Python documentation says that when you convert a float to an int, it truncates. That's a fancy word that means it just chops off the decimal part. It does not round. So if you do int 3.9, you don't get 4, you get 3. The 0.9 is just thrown away. Remember that. It'll save you from some very confusing bugs later on. Okay, enough theory. Let's get our hands dirty. It's time for a lab where we'll apply this to a real-world scenario you're going to use all the time, taking input from a user and actually using it in a calculation. First thing, we use the input function to ask the user to type something. Now, burn this into your memory. The input function always gives you a string. Always. It doesn't matter if the user types the number 7 or the word hello. To Python, it's just a sequence of characters, a string. And if you don't believe me, we can prove it. We use the type function to ask Python, hey, what kind of data is this? And look at the output. Class string. Confirmed. It's a string. So what happens when we try to do math with our new string? We try to multiply it by 10 and bam, type error. The program crashes. Python is telling you, I can't do multiplication on a piece of text. It makes no sense. We have to convert it first. And here it is, the solution. We take that user input string and we wrap it inside our int function. That is the explicit command. We are casting that string into an integer. Now that it's a proper number, we can multiply it by 10, no problem at all. Finally, we can print out the correct result. The whole thing works flawlessly, but only because we took control. We saw the string, and we explicitly told Python how to convert it so we could do our calculation. That's typecasting in action.
All right, we're almost at the end. But before I let you go, I have one last challenge for you. This is to make sure you're actually thinking like a programmer and not just following recipes.
So here's the scenario. Your code is expecting a whole number, so you're using int to convert what the user types. But what if the user enters 3.14? What's going to happen? Is the program going to crash? And more importantly, what function should you have used to handle that kind of input gracefully? Your assignment is to go find out. Write the code, run it, and see what happens. This will prepare you for our future lessons on handling errors. Class dismissed.